What about this one? Br2, and remember, bromine's a liquid. Oh, it's a cool liquid. It's a fuming liquid. It's kind of right on the point where it'll, on the transition between a liquid and a gas at room temperature. So I've got bromine. I've got potassium chloride. This looks like it's going to set up for this. The problem is, this is no reaction. What? What? Yeah, Mr. Wright, what are you doing? Oh boy. Okay, so the question is, how do we tell when this is going to happen? We're going to use something called an activity series, but we're not going to do that today. Today I want you to just focus on learning the types of reactions. Okay, so we'll leave that till next time. Alright, so that takes us to our next type of reaction, double displacement reactions. In double displacement reactions, the ions of two compounds exchange places in an aqueous solution to form two new compounds. Okay? It's like if you're at a dance and you're doing like a square dance and you change partners with the other group. Everybody's changed partners. Everybody has something new. Okay? So these are both going to be ionic compounds. That's how you identify this type. You're going to start with two ionic compounds, and you're going to form two new ionic compounds. Okay, everybody just flips. So formation of a precipitate. Okay, so here there are a bunch of compounds, and we're going to talk a little bit more about this next time, that, where you'll start with two aqueous solutions and you'll form a solid. Okay, that's called a precipitate. And this is one of the ways that you can drive one of these double displacement reactions. So you'll notice here that I have a transition metal in here. Well, what do you do with the transition metals? In the past, I've had to tell you what to do. Here, transition metals, because they have a charge, right? They're part of ionic compounds. Just say that TMs will keep their charge, and that's kind of important. Okay, otherwise you can't do it. So transition metals will keep their charge. The other way that you can do this double displacement reaction is for the very rare cases where instead of forming a solid, you're going to form a gas. Now this almost never happens, but I could ask you. All right, so now I need to write my compounds. Well, I know that iron is going to team up with the chlorine, and the hydrogen is going to team up with the sulfur. So let's write the iron one first. So this is going to be iron, and it's going to have the same charge, right? So here the iron has a charge of +2. So this is iron 2 chloride. Okay, it's again an ionic compound. So that's Fe2 plus chloride is Cl minus, so I'll need two of those. So my compound is FeCl2. Okay, this is an aqueous compound, which we'll talk about a little bit more next time. All right, and then the other product is going to be hydrogen sulfide. Okay. That's how we're going to treat it. Okay, so that's H plus and S2 minus, so that's going to be H2S. It's only two hydrogens. So this is going to be a gas. All right, and again, I'm going to have to give you some prompts along the way because I don't want you to be memorizing, that hydrogen sulfide is always a gas. Okay. The other way that we can do this is the formation of water or another very stable covalent compound. All right, so we've got HCl and NaOH. So the H is going to team up with the OH. There we go. That looks like it's going to be our water. And then the Na is going to team up with our Cl. So I'm going to get H and OH, which is water. Okay, hydrogen hydroxide, also known as water, H2O. Plus sodium chloride. Okay, which is just NaCl. We should know that one by now. That's aqueous, it's always soluble, and then I can go back and balance. Everything's already balanced. Great. Oh, no. I needed two in front of there, and a 2 in front of there, and a 2 in front of here. No. Wait. Just kidding. It was balanced originally. Silly Mr. Ryan, trying to make things too difficult. Which brings me to another point. Don't try to make things too difficult. Okay? I was kind of looking at two things at once and realizing that that was not balanced and should be, so I'll go back up and put that in. Okay. So, that is double displacement reactions. All right, and we're gonna talk more about those tomorrow as well. In a combustion reaction, a substance combines with oxygen, releasing a large amount of energy in the form of light and heat. Okay? We're basically going to talk about one type of combustion reaction, and that's if you have a hydrocarbon. Now, hydrocarbons, okay, contain hydrogen and carbon. And that's all, okay. So the problem here is I might sometimes give you some compounds with oxygen as well, okay, because it's reacting with oxygen. So if the compound has oxygen in it, it's kind of okay. You just do the same thing. But the nice thing about this is that the products of this are always CO2 and water, okay? So here's C3H6 plus O2. So this just has carbon, hydrogen, reacts with oxygen. So this is a combustion reaction, okay? So this is a combustion with a hydrocarbon. So my compounds are going to be CO2 plus H2O. Now the tricky thing about these, I mean, I'm just giving you stuff, right? So really the only tricky thing here is it can be balancing, all right? So for instance, if I do a 3-3, if I do 3 and 3 here to balance the hydrogen and the carbons, I get 6 plus 3 is 9 oxygens, so this is going to have to be 9 halves. So I'm just going to have to go through and multiply everything by 2. Okay, so 2, 9, 6, 6. The balancing on these can be a little tricky. If you use the fraction method, you'll never have a problem. All right, now again, you could see something like C2H4O2 plus O2 yields, and I want you to know that this is still close enough to a hydrocarbon that it's CO2 plus H2O, okay? And I'm not even going to balance that, okay? So those are all the types of reactions that I want you to know.